Hello, everyone. So as I told you guys, I am out today. But it is very important that you complete all of your work as this is a new solid 3D object that we are learning today. So the last few days we have been working on finding the volume of a cylinder. Today we're going to start looking at a cone. But to do that, we're going to look at cylinders, kind of review cylinders, and then look at what if I took cylinders and stacked them on top of each other. So for this one, we are going to find the volume for this cylinder. Remember, our volume formula for a cylinder is pi radius squared times the height. So for A, that's going to be V equals pi. Our radius is 2. So 2 squared times our height. The height of this is 6. So 2 squared is 4. 2 squared is 4. 4 times 6 is 24. So the volume of A is 24 pi. Don't forget the pi symbol. If you just put 24, it's not going to fill up all the way. But if you put 24 pi, it's going to fill up all the way. So make sure you don't forget those pi symbols. Okay. This one is slightly different because we have a base cylinder. It's got the same radius, 2, and then the height is half of that. Then the cylinder on top has a radius of half of that, and then the other half of the height. So the height between both of them is the same height as this total one. But we're just going to focus on finding the volume of the bottom cylinder and the volume of the top cylinder. So basically what we're wanting to do to find the volume of the whole thing is the volume would be pi r squared h for the first one plus pi r squared h of the second. So let's figure out this bottom one first. This bottom cylinder is going to be pi 2 squared times 3. 2 squared is 4. 4 times 3 is 12. So this bottom one is 12 pi. So this first part is 12 pi plus our other one. So our second one here, we have pi times our radius for this one is 1. So 1 squared times the height of 3. 1 squared is 1. 1 times 3 is 3. So the volume of this smaller cylinder on top is 3 pi. So together we have 12 pi plus 3 pi. Think of this as like terms almost. They are like terms, 12 pi plus 3 pi. So we can just add them. 12 plus 3 is 15. So this would be 15. And this is going to come in handy today. So we're going to now look at kind of what happens to the volume. If we took a normal cylinder, so similar to this one here, we took a normal cylinder, a big cylinder. We then kind of cut it in half and made both things smaller. So 2 cylinders where the bottom cylinder has the same radius as the original, and their height of both of them together is the same. Notice that A was 24 pi, where B was 15 pi. So what would happen to these ones? If I took this one, would this cylinder have a larger or smaller volume than these 2 cylinders together? And would these ones be larger or smaller volume than this one? And then what about a cone? Would a cone have a larger volume or a smaller volume than the other ones? So go ahead, take a guess on your paper. Take a guess on your paper. Okay, so thinking back to the like warm up page, these two cylinders had a smaller volume than the one big cylinder. So if I kind of put this on top of it, you can see that these two smaller cylinders fit inside of the big one. So that means our two cylinders should definitely be smaller than our one cylinder. If I look at my four cylinders, those ones all also fit inside of the one big one. If I put it on top of the two, you can see that the two cylinders on the bottom, these two cylinders on the bottom fit inside the bottom cylinder, where the two cylinders on top fit inside of the top cylinder of the two. So the four cylinders is even smaller than the two. And if I look at the cone, notice the cone is inside of all of these. So as they are getting smaller, or as they're getting smaller and as we're adding more cylinders to it, it's becoming more and more cone-like. See ya. So the cone is the smallest of all of them. So least to greatest, your cone is the least, the one cylinder is the greatest. Okay, so this says drag the slider back and forth. What do you think the exact volume of the cone is? So this is where it gets a little kind of confusing because it says exact volume. And if you guys look at your paper and what I'm about to show you, it looks like a cone in the middle one. So you have on yours, you have a cylinder, you have what looks like a cone with like lines in it, but it says 25 cylinders under it. And then you have the cone next to it. Right now, this says two cylinders, and I'm able to drag this slider to add more and more. Okay. So what you have right now is something like, I'm pretty sure your paper says 25 of them. Okay. On mine, you can see that this is like individual cylinders, and we have 8.49 pi. As I keep getting smaller and smaller and smaller, it's starting to look more and more like a cone. But it's not exactly a cone, it's 250 cylinders. Okay. So my big one cylinder is 24 pi. Two cylinders is 15 pi. I'm getting smaller and smaller and smaller. And if you look at our volume with the approximate symbol sign, it's getting smaller and smaller and smaller, but it's not going down as fast as it was originally. It was originally going from 24 down to 15, 15 down to 12.44. And then it starts to get smaller and smaller, but not by as much. And it's getting smaller and smaller closer to a specific number. Okay, so what do you think the actual cone's volume is? This one I'm not going to tell you just yet. So go ahead, take a guess. Okay. Let's go back a second because it does say to take a guess and then explain, and then it jumps me right into this next one. Okay. So I do kind of want to go over this. I lied. I am going to tell you, like, discuss this with you right away. So if you notice, as we add more cylinders, probably at around 13 cylinders, 12 cylinders, we start getting, no, 12 is 9.03. Hold on, hold on. Okay, 13, we have 8.95. So it's between 8 and 9, starting at 13. And even all the way at 250, it's still between 8 and 9. So it's getting smaller and smaller and smaller, closer to 8, but it's not been 8 yet. And that's because the cone is 8 pi. Okay. Now, if you notice, going from 24 pi down to 8 pi, think about what that means. Going from 24 down to 8, because that's going to help you with our next slide. But explaining every time we add a cylinder, it gets closer and closer to 8 pi. So now this one says, here's another set of figures. We have the cylinder and we have a cone that has the same radius and the same height as the cylinder. It is the same radius and the same height as the cylinder. Estimate the volume. So what do you think the volume might be based on the fact that the last one went from 24 pi down to 8? Okay, if you guessed 10 pi, you are correct. And that is because if you see here, it's getting smaller and smaller and smaller, closer and closer, like adding more and more cylinders, getting closer and closer to 10 pi. Okay, so what is happening? How are we going from 30 pi to 10 pi? How do we go from 24 pi to 8 pi? We are dividing by 3. If you have a cone with the same base and same height as a cylinder, you can just take the cylinder's volume and divide it by 3. A cone is 1/3 of a cylinder. A cone is 1/3 of a cylinder. So looking at this here are the two examples we just did, 24 pi down to 8 pi, 30 pi, 10 pi. Here we have a cylinder with a volume of 120 pi. What would the volume of that cone be? If you did 1/3 of 120, so 120 divided by 3, you should have gotten 40 pi. Here we have a cylinder that is 60 pi. If the cylinder is 60 pi, what would the volume of the cone be? If you did 1/3 of 60, 60 divided by 3, you should have gotten 20 pi. Okay, and then this one is working backwards. You have a cone with a volume of 15 pi. This is going to be 1/3 of the cylinder. So we have to multiply this 15 by 1/3. So if this cone has a volume of 15 pi, what would be the volume of the cylinder? If you said 45 pi, then that is correct. 15 times 3 is 45. So 45 pi. So a cone is 1/3 of a cylinder. That is kind of the main thing that you need to know is that a cone is going to be 1/3 of a cylinder with the same radius, base, and the same height. Okay, so our next problem number 6 says one way of writing a formula for the volume of a cylinder with radius r and height is v equals pi r squared h. This is what we have been doing. This is what we did on the very first slide. Write the formula for the volume of a cone. Well, we just said that the cone is 1/3 of the cylinder. If the cylinder and the cone have the same radius and the same height, then the cone is going to be 1/3 of the cylinder. So the equation is going to be the same as the cylinder, but 1/3 of it. So it's going to be 1/3 times pi radius squared h. This is the formula that you will see on MCAP in high school. Google, like this is the formula for the volume of a cone. It is 1/3 pi radius squared h. So the cone, the only difference between a cone and a cylinder, you're still going to do those same steps. Square the radius, multiply the height, then divide by 3. The only difference is that you're now going to divide by 3. Just like how with a triangle, you would do length times width divided by 2. With this, you're going to do the same thing as your cylinder, but divide by 3. Okay, so slide 7 here, let's go ahead and do those steps to solve. This is your radius here. Even though it's at the bottom, it's taking you from the point, the center of your cone, to the edge. So that is your radius. That 4 inches is your radius. So volume equals 1/3. Hold on 1 second, hun. Sorry about that, guys. Okay, so we have 1/3 pi times our radius. So we said our radius is 4 squared, radius squared, times our height. The height of our cone is 6. So all I did was I took the formula and I just plugged in the radius for R and the height for 6, or the height for H. Now I can just go ahead and solve. So I have 1/3 pi, 1/3 pi, hello, type pi, times 4 squared. 4 squared is 16 times 6. Okay, so now I'm going to do 1/3 pi times 16 times 6. You are allowed to use a calculator for this unit, friends. And you should have gotten 96 for that. 16 times 6 is 96. At least let me double check with my calculator. Okay, yeah, right. Okay, and so now to multiply that 1/3, again, I always leave pi for the end. Even though it's kind of in the beginning, we always leave that for the end. So then 1/3 of 96, or 96 divided by, so 96 divided by 3 is going to give you 32. 96 divided by 3 is 32. So 32 pi is your volume for this cone. 32 pi is our answer for the volume of this. Okay. So when I click check my work on the Desmos, you can see that that is correct. Those are the steps for doing it. So I'm going to click that edit response so you can see all the work again. Please make sure you are putting all of this work onto your paper. Okay. Question number 8. So this one is kind of going backwards, kind of like what we did in class yesterday with going backwards for cylinders. Now we have our cone and we're going backwards for finding the height of the cone. So we know the radius is 6, the height is missing, our volume is 60 pi. So as always, I'm going to start off with writing the formula at the top. So the volume is 1/3 pi radius squared times the height. And now I'm going to substitute in what I know. So I know my volume is 60 pi. You see how much easier it is when you just leave it as 60 pi instead of doing 60 times pi. It's going to make all of this so much easier. Okay, so then 1/3 pi, the radius squared is 6 squared. 6 squared. And then times our missing height. So the height is what we have to solve for. Okay. So I'm going to go ahead and simplify my right side. So I'm going to keep the left as 60 pi. I'm going to do 1/3 pi times 6 squared. 6 squared is 36. So I'm just going to make that 36 and then times h. And I'm going to simplify it some more by figuring out what 1/3 of 36 is. So 60 pi, 1/3 of 36. So 36 divided by 3 gives me 12. So this is going to be 12 pi times h. And now I can divide 12 pi on both sides. So I'm going to do, is there like a little division thing? No. Okay, hold on. Let me go in so I can make this a little bit better. Okay, so I'm going to divide 12 pi on both sides. Go back, go back, go back. Divide 12 pi times h. There we go. This is a lot more difficult to do when I'm doing it on the computer and you guys are doing it on paper. So the top part here, that 60 pi equals 12 pi h, is me simplifying the top, and then I'm dividing 12 pi from both sides to get the h by itself. Because this is being times h, I have to do the opposite or the inverse. So I'm dividing by 12 pi. 60 pi divided by 12 pi leaves me with 5. Because the pi's cancel out. 60 divided by 12 is 5. So my height of the cone is 5. This will do like a little, like some more practice when we all come back on Monday. But your practice for the rest of class today is just practicing finding that volume. Okay, we are going to skip this section. So this section of your packet, you can just skip. Okay. One way of writing the formula for the volume of a cone is 1/3 pi r squared times height. What does each part of the formula represent? So what does the V represent? What does the 1/3, where did that 1/3 come from? What does the R represent? And what does the height represent? Go ahead, answer this on your paper. I'm not answering this one for you. Answer this one on your paper. Okay. Question 11, which figure has a greater volume? So notice now, don't just automatically assume it's the cylinder because of what we did in the beginning of this Desmos. Because they do not have the same radius and the same height. So you're going to have to solve for them both separately. So again, our cone is V equals 1/3 pi radius squared times the height, where our cylinder is V equals pi radius squared times the height without doing that one. We need to fill in this information. So for the cone, it's going to be 1/3 pi times our radius here is 3. So 3 squared times 6. And the cylinder, we don't have to do that 1/3 for, so it's just going to be pi times our radius for the cylinder is 2. So 2 squared times 5. Okay, so the cylinder does have a smaller radius and a smaller height than the cone. But the cone you have to take 1/3 of. So which one has the greater volume? And then I think it makes you explain. Yeah, it does make you explain. So go ahead, solve this on your paper. I'm not helping you out anymore from here because the rest of this you can do in your calculator. So put this all in the calculator and solve to see which of these is the larger shape or has the greater volume. Okay. And then at the bottom of your paper, actually, you know what? The show what you know is on one sheet. It's kind of on like a different sheet of your packet. On either the very last page or the page before it, I can't remember, it is going to still have the little smiley faces. So please circle, tell me how well did you understand the math lesson for today and how did you feel about this lesson? So can you use the formula to calculate the volume of a cone? And can you describe the relationship between a cone and a cylinder with the same base and the same height? So do you know the relationship? Do you know how to find the volume of a cone if I gave you the volume of a cylinder with the same information? And then can you use the formula for a cone to find its volume? Okay. And then you guys will have some more volume of a cone practice, and I might throw in some more cylinder practice in the Nearpod. If you finish the Nearpod before the end of class, go ahead and work on ALEKS some more because your 225 topics are due today. I will be putting in the ALEKS grade tomorrow. Okay? The grade for ALEKS will be put in tomorrow. Now, I do work early at 7 brew tomorrow. So you do have a little bit of time in the morning tomorrow to get your topics up. The more topics up you get, the better your grade will be. So please, please, please make sure you're working on your ALEKS trying to get those topics up. Okay, I will see you guys all on Monday. Have a great weekend and finish up your Nearpod.